I'm Jason Domizio. I'm a senior staff software engineer. That's what all the S's and the E is at Black Diamond. I don't know if you, we're a local shop here in town. We deal with wealth management, financial advisors and their clients, and we make a web platform for them. Really fun place to work, and we're always looking for talented people. Just to, now that I have that out of the way, we can actually go what you're actually interested in. And if there's anything that you should take from this talk at all, is that I have the coolest email address in the universe. So, so dynamic cheese, what does that mean? It's kind of a clickbaity title. Yeah. Well, let's start with a little quote here, because that seems pretty fancy. Sometimes the fastest way to get to the end is to throw everything out and start over, by a guy named David Aiken. And he has, in this link here, and you'll be able to download the slides and stuff later, that these laws of spacecraft engineering, there's like 40 or so laws, but a lot of them actually apply pretty well to software engineering as well. So, or sometimes life, I don't know. But I thought it was interesting, and but it kind of explains a little bit about why your .NET cheese has moved. A lot of you, how many of you are .NET developers? Oh, yeah. How many of you use the old full framework, the 4.71 or something like that, right? How many of you have used the .NET Core framework? Right, so maybe like about half. So some things that you're used to are not the things you're used to anymore. And this is primarily what I wanted to talk about, a few things. A lot of the people are probably going to talk about MVC and stuff like that. And I'm going to talk about some of the less glamorous things, but hopefully not in a less glamorous way. In particular, a lot of the things in .NET that have changed is like there's less global context. So like HTTP context.current, right, is not there because there's a better way. There's new configuration paradigms. App.config, not really, you still can have it, but it's not the only thing that you have. And there's more Microsoft supported stuff that is available. And then there's been a rise in all over our development community about structured logging, right? So like being able to have a machine parse your logs and stuff like that too. Oh, look. So again, things I'm not focusing on this presentation because honestly, they're probably pretty in-depth themselves. Things like entity framework, digging deep into ASP.NET Core, identity and access management. These things have changed too, right? But again, they're probably a little bit lengthy for an hour. If you haven't taken a look at .NET Core at all, these are some of the main things to take away. That the runtime and the framework have separated, right? So the thing that runs your code is not necessarily all the features that you have in your code. And actually, the framework is pretty much downloaded via NuGet. So that means that Microsoft and everybody can move on a faster release cycle and have less breaking changes for your code that you're developing. And the other thing is that you can have self-contained apps. Things can be published in a way that you can essentially run your program on something that doesn't have .NET and the .NET framework installed at all. So that's nice for portability, nice for Docker, stuff like that. Another confusing thing in the .NET world is probably these words here. People refer to the full framework as like NetFX, and then there's .NET Core. These are the runtimes. These are the things that are running code. And then there's this thing called Net Standard, and it is essentially the stuff that is guaranteed to work in any framework. So you can create a library that is Net Standard, have it run on the full framework, or have it run on .NET Core. You can also have it run on Mono and anything else that supports the .NET Standard. So there's a strange compatibility guide on the Microsoft website that shows what the .NET Standard levels mean, because they keep on adding stuff that is supported under there. With .NET Standard 2, it is very, very close to parity with the old framework. So the first thing I want to talk about is dependency injection. And that kind of makes the new .NET framework solid. So what is dependency injection? Well, hopefully it's not going to be that painful. First, before we get in there, let's get a little bit of solid. So what is this? Solid is a set of design principles for creating like very manageable object-oriented kind of software. If you're a functional programmer, dependency injection might not really matter to you. But for the style of software that you have with C# and dependency injection has really been embraced amongst the framework and is a very powerful tool. And it's composed of a few principles. I'm not going to go too deep into them, but like there's a single responsibility principle, which means that you have a piece of code that should do one thing, do it well. The open and close principle, which means your code should be open for extension but closed for modification. The Liskov substitution principle, so when you have something that's derived, right? If you change the implementation of that thing, you should not change the calling code or not have to change the calling code so that it can work, right? So things are substitutable. If interface segregation, which means, hey, it's probably a good idea to take your interfaces and then segment them down into smaller pieces that are more focused and responsible. And then there's dependency inversion. And I just want to say, dependency inversion is not the same thing as dependency injection. They're actually two different things. Dependency inversion just means that something else should be calling your code, that your code should not be super coupled to each other, right? You should have something else kind of assembling it. And the thing that could assemble it might be a dependency injection framework. There's three big things in DI. It's not just composition, right? There was this Microsoft library called Managed Extensibility Framework, MEF. And it only handles the first thing out of these three things. And so it is not necessarily a dependency injection framework because it can't do those other things. But composition is basically like, how are your objects composed, right? How, if I have a constructor in one of my pieces of code that takes this dependency, like who's going to put it in there? Right? What kind of implementation is it going to get? That's one of the things that dependency injection handles. It also handles lifetime. How many of you know the singleton pattern? Right? So with the dependency injection framework, that pattern is essentially useless because the dependency injection framework can handle creating one instance, managing that single instance, and then when you need to not have it be a single instance anymore, you can change the lifetime of it. You can also scope things per request. So you have a single instance being shared for like a web request or a worker request. And then the last thing is not very widely used, but it's called interception. So like you have a service that calls into another web service or something, and that service goes down, right? You have to have something, a common pattern there is called the circuit breaker pattern, where, hey, to be a good consumer of this stuff, I don't want to over-request and cause more problems and have that thing be down more. I want to back off, maybe have an exponential back off. Interception would allow me to take a lot of services and code something around them that would handle that pattern without my actual code that calls the service having to be aware of it. It's kind of like aspect-oriented programming, if anybody's ever heard of that, but I guess it's not really very widely used, at least not by me. Maybe other people use it a lot, I don't know. Dependency injection also kind of matters how you do it, right? There's a thing called the service locator pattern, where it handles like the composition of stuff. Go fetch me a required service, but that violates the D in solid, right? The dependency inversion. You are telling your code to have an explicit coupling to some implementation of something. It might be flexible. You might be able to substitute stuff out, but it isn't dependency injection. Service locator is still used in dependency injection. It's just used as something called the composition route. And I'll show you a little example about this a little later. The composition route is basically the place where you register all of your dependencies and then resolve them. And then classes should be written for constructor injection primarily, right? There might be cases where you need other things like property injection or method injection, but basically try to be declarative in the dependencies that your class takes, hold on to them, and that way that you can have a maintainable dependency injection experience. So I need to pull together here, right? Lisnia. The Microsoft.extensions.dependency injection. This is Microsoft's newish NuGet package for dependency injection. There's a lot of dependency injection frameworks around there, or in the community. There's stuff like Structure Map, AutoMap, or AutoFac, and like Simple Injector, stuff like that. The good news is all this stuff generally is pretty compatible with each other. They have ways, adapters, to allow the framework stuff to interact with the dependency injection framework of your choice. So you don't have to use Microsoft's, but you can interoperate with something that does use Microsoft's. And there's two major classes that really, you probably want to focus on with these things. There's the service collection, which basically allows you to declare dependencies and lifetimes, and its other job is to build a service provider. Then there's the service provider. This is the service locator, right? A lot of frameworks like MVC abstract this guy out from you. Some, if you're using like a console program, you might have to actually use this thing. But it basically is the point in which you resolve the thing that you are trying to get. Stimma time. Let's use a little DI. So I have a little program here. I don't know, if you take a look at it, it's a guessing game. Everybody's probably written one of these things. I'm going to go way overkill on this thing because no guessing game should probably have dependency injection on it, but it's a convenient example. As you see, like we get the min, the max number that we want to do, generate a new random number, get a guess, and then do it until we guess something right. Well, what we can do, I'm gonna do this the easy way since this is only an hour. An hour is not necessarily a whole bunch of time. I'm gonna copy this guy. I'm gonna replace our little program here and introduce some things. So this line I just uncommented. This is me building a service collection. Very easy. Hopefully everybody's familiar with the new command. And what I'm doing here is I'm adding something to register to the service collection. And what I'm saying there, add transient, that means it's a transient dependency. That means every time I request it, it's going to make a new version of that thing. So anytime you see this in a constructor, this random number, which we would see in this console, nope. Is that the guy? Local guessing game, right? We have a random number that gets injected through the constructor and gets put in here. And every time we new up something here, right, we're gonna get a new version of that. Next, I'm going to add an implementation of a guessing game, right? This says, when I see guessing game, I want you to resolve the local guessing game. The next thing I have here is adding a singleton, right? So for this random number, like this is the system.whatever.random, what is it? System.random.random. It basically says that I'm going to have one instance across all dependencies of that random. And finally, I have this guess factory. Again, this little enterprise fizzbuzz. It is way overkill for a console guessing game, but just try to show some of these concepts. One other thing, because I was lazy and my conference slot was earlier than I expected, is I have to add logging to it right now, a little early, because otherwise the program breaks. So, and then finally, over here, what we're doing is we're building the service provider. This is basically taking all the configuration we handed it and basically making it real. Out of the service provider, we resolve a service, this iGuessing game. And from what we had put right here, right? We are going to get the instance of local guessing game. And the local guessing game is going to have a random number assigned to it. It's going to have an iGuess factory implementation there. It's also going to have an iLogger. If we run it, here's the moment of truth. It's the first time I've ever done it, and it's front of an audience. Oh, look, it worked. So, numbers lower, 25. Numbers lower. This is very exciting. 6, 7. Oh, I win! Yay! I guess that's cool. Yeah. Oh, thank you. I could also do something else that's interesting but boring. I have this random number guess factory, right? So with dependency injection, I can go and substitute an implementation pretty easily. So if I run this guy again, oh, look, it just did the game for me. Yeah.
Just to be clear, though, on the same page as you, that's the .NET Core dependency injection.
Yes, that is Microsoft.extensions.dependency injection. That is not AutoFac. That is not simple injector or anything like that. Personally, opinion time, I prefer AutoFac. It gives you a little bit more flexibility in things. Like it can interpret the fact that you registered an I something, and you can depend upon a func of I somethings, and now you have a factory. If you have an I enumerable I somethings, right, you would get every implementation that you have available of those I somethings, right? And so it just allows you to be a little bit more flexible with the calling code. If you like, if you're interested in dependency injection, I have some links in here. But just to make this point, the dependency injection helps object-oriented software be solid, right? The next slide, I'll show you a link to a book that is very, very helpful in understanding dependency injection, the concept, and also the solid principles, the concept. But that's just the major point. And that's probably why Microsoft really heavily invested in that, and when they rebuilt .NET from the ground up, they did it with dependency injection in mind. So here's a link to that book. It is a somewhat dry read. It's interesting in some parts. Like it talks all about food, and I like food, maybe obviously. But if you ever want to look more into that, I would recommend this book. Let's talk about configuration. It's not just app config anymore. And oh look, actually let's get rid of app configs. I hate those things. So what's new? You're going to see a pattern here. This Microsoft.extensions.blah, Microsoft.extensions.configuration. Basically, they've made an abstraction around configuration that's really easy to use. It boils down to key value pairs, and those key value pairs can be hierarchical. It's built via this class called a configuration builder, and accessed via something called an iConfiguration. You can have multiple sources represented in one iConfiguration. So like if you have a file base, like a JSON file, XML file, any file, environment variables, command line, you have your own thing, your special sauce, right? You can boil all those things down into one configuration that is consistent for your program. And then you can order them, right? So say I have configuration in a file. Well, I can take that configuration in the file and amend it with command line information, or maybe environment variables. Maybe depending upon your environment, you might have different things set, and you might have a default thing. Maybe you have a file that you drop in there in case something is going wrong and you want to add debug level logging or something like that, right? These are all things you can do really easily with this new configuration abstraction. Only downside is, really isn't a real clear way back to the stuff that's already there, app config. There is a NuGet package for app config, but it's kind of hit or miss. So here we have a configuration builder. That's too much code. Nope. You zoom in a little bit. Oh. Things are going wacky. All right. I tried to be nice and zoom in. But anyway, so what we're doing here is we're setting a base path, adding a JSON file, and actually we can tell it anytime the JSON file changes, we can reload our configuration and have a new configuration. And we can say it's not optional, right? Or we can have an optional one. If it's optional, then you may not put it, deploy it with your program. It may look for it, like I just said, in the case where something is going wrong or you want to override something. and also adding environment variables here. The last little add there shows that these things are extension methods, these add JSON files, add environment variables, that under the hood basically do this stuff. They make a new JSON configuration source and configure it and stuff like that, and then finally build it. There's this interface, this important distinction here, right? For an iConfiguration, there's also an iConfiguration root. You should probably use the iConfiguration. It's not very common you actually need an iConfiguration root. Really, the only difference between those two things is the iConfiguration root can be reloaded. It can signal that the configuration needs to be reloaded. And it can also reference the configuration providers that are composing the configuration. So if you had to reach back down and say, like, oh, I really need to know that it's configured this way in this file versus the environment variables, well, that's how you would do that. iConfiguration. So here's an example of a program where we are passing in an iConfiguration. And so what this is showing is that how you get a value out of your configuration. You can reference it if it's at the top level by some key, or via this hierarchy, like key, colon, key, right, all the way down the hierarchy. And you can also get types back out of it. How many of you used like app settings in app.config and had a string and then had to parse stuff, and then, yeah, that's ugly and it sucks. So like, try this other package, Microsoft.extensions.configuration.binder. That's what gives you that get value, and it makes life a lot easier. You can also bind configuration to plain old CLR objects, right? So iConfiguration.bind basically allows you to say we have a configuration passed into this run method here. We make some object. We get this section program and bind to the results. Now all the settings on that it could find in that configuration are set on that object. This is really useful when combined back with our dependency injection stuff, right? Because there are a lot of things like add this service, add that service, add all these dependencies, and they'll give you basically an object to help you further configure your dependency that you're adding, right? And sometimes you might want to do it via code, right? Sometimes if you want to be more stable, you'd want to have it configured via some sort of configuration. And here's an example of that, right? I'm adding this anti-forgery stuff for MVC, right? I can get a section called anti-forgery with all the options and just set them on the object. You can be notified of changes in configurations. Say you need to log when a configuration has changed so that you can have some sort of auditing or something like that. It's like, hey, nobody changed the configuration overnight or something on me. Well, this change token to onchange is a static method that's available in Microsoft.extensions.primitives, and it uses this iConfiguration.getReload token. So this is just a way to signal things, and iChange tokens, not something I'm going to go into, but they're a way in the new framework to basically tell you stuff changes. But where are my strong types at? Disclaimer, but we use a strongly typed language, and we probably like to have those things. All the other stuff I add is basically like, here's a lot of strings, and let me get to this value, right? So there's a thing called the options pattern, right? You'll see this as well. Basically, you have strongly typed configuration available via objects that you create. They're in Microsoft.extensions.options and options.configuration. And there are a couple of different flavors of it, right? And this really goes back to, this is hooking options hook up with the dependency injection stuff. So you have a call to this thing called .add options, right? And there's this other thing called .configure, right? And if you resolve an iOptions, well, what you're going to get is the original options that were bound when the DI container started. If you get an iOptions snapshot, it's going to be request at a scope level. So like, think about a request, right? If you have a long-running request, maybe you wouldn't want your configuration to change in the middle of that request if you wanted to be aware of changes, because the last thing, iOptions monitor, basically always gives you the current value of whatever the options are. So in a long-running request, if you call .current value, it might change in the middle of your execution. here's another long-winded example. It's like this services.configure setting options. Basically, I'm telling it to bind the options to a section in my configuration, or I can just give it a section and it'll do it itself. And then these are examples of using the iOptions monitor, that you can get settings.value.setting1, settings.current.value.setting1. The important thing is that you see this iOptions, right, the wrapper, right? That's what you have to inject, and that's what you use to tell it, to signal it what kind of lifetime that you want for your options. Let's configure stuff. All right. I don't know if I had a demo for this. I think I got bamboozled for this one. Let me see. No, I might not have a demo for this. I'm very sorry. Essentially, I'll explain to you what I was going to do, and you can be impressed by that. Essentially, I was going to take that guessing game, and I was going to show you that section where the dependency injection was happening. I switched between the two different things. Well, I can just look at the configuration and change it. One of the useful things is that you should get out of this is that if I change my configuration, I have it set in this appsettings.json guy. You see a password here, 1, 2, 3, 4, 5. Doesn't really mean anything since I never checked the password anyway. So anyway, this guy here, if I change anything in there, it changes at runtime. And so I don't have to restart the program, don't have to reload stuff. That's a pretty powerful thing, and I'll show it a little later in our logging example. Again, app config versus app iConfiguration. App config, I don't know if you remember, is loaded during your app domain initialization as part of the program starting up. You only really get XML. You get strong types through making these derived configuration sections and declaring them up front and then using them in your app config. Versus iConfiguration, where it's kind of loaded where you want to choose to load it. Usually it would be in your composition root. Has many formats and has strong types through iOptions. Logging. Yeah, this is kind of how I feel about logging sometimes. I don't know if anybody's ever seen this movie or Troll 2. It is probably the worst movie ever made. It is about a group of innocent. It has no relation to Troll 1, by the way. Well, there was a Troll 1, it's a horror movie, and there's Troll 2, which is about these goblins. It's about goblins. It's not about trolls. It's about these goblins who turn people into vegetables and eat them. And so this is the guy's realization that his parents been turned into a tree or something like that. I can't, yeah, that's very relevant to logging. Yeah. And if you've used log frameworks, there's a lot of them. There's console or write line, Serolog, common logging, log4net, nlog, just to name a few. I'm not sure there's more than 5, but I don't know. Why can't they all talk together? Anyway, I talked a little bit earlier about structured logging, right? So just this little definition, basic logging is logging of messages, and maybe machine readable, but it's probably more human readable than machine readable. And structured logs can be human readable and machine readable. It just allows us to get better context into the thing that we're doing so that we can get to our problems faster, or even have stuff like alerts. There's programs like Graylog or Splunk and stuff like that that can process our logs, give us alerts when stuff's going wrong over a certain error rate or things like that. The framework uses this stuff, right? So framework can give you a lot of logging. If you're using MVC, you can get a lot of information out there. You turn that thing to trace, and man, that thing is going to blow by. So Microsoft.extensions.logging, that follows our usual pattern of namespaces here. We have these couple of interfaces and classes and stuff. We have an iLogger factory, creates loggers. That's pretty simple. We have an iLogger of T. It can scope a logger to a type. So why would you do that? Well, one of the cool things you can do is that you can scope your logs. And some frameworks can already do this, right? But they've really kind of made this generic interface over this stuff, is that you can scope your logs in your configuration to a namespace, to a class. Have you ever had something go wrong in production, and you'd say, hey, I need to turn the logs up to debug level. And they're like, no, that's going to fill up the drive. We can't do that. Like, well, I can't solve the problem without it. Well, with this, you can kind of focus. Like, I know what's going wrong in these two classes, so I'm going to override the logging on these particular classes to be debug, and everything else can be normal. And then there's another thing called logger.begin scope. Essentially, that is putting extra contextual information on the log message. So you think about a MVC request, right? You have a request ID, right? Wouldn't it be nice to see, hey, for every log message, you could correlate that stuff back to whatever request it came from, right? This is what begin scope allows you to do. Yeah, but I like my other logging framework. Well, things are very compatible in the .NET Core world. You can still use your preferred logging framework. I prefer Serolog. With Serolog, you can configure virtually everything about Serolog via the configuration file. Now, that's not so great for getting something started, but when it's in production, that's a huge boon. Like, hey, I want to log the gray log, I want to log to the console, I want to log to the event log. Well, I can configure those things, or I can turn them off or log at different levels on those things. Most of the major logging implementations have adapters that allow them to integrate with this package so that you can get information from MVC, from all the things that Microsoft's created, from top shelf if you're using that, right? You can see what every part of your program is doing and not just the part that you wrote. Demo time. So I'm going to remember how to load a different project. So if you see down here, it's running stuff and it's logging stuff. Oh man, that's very, very exciting. It's doing things. In fact, all the things are called like thing doer and thing processor. I'm very good at naming things. But if we go over here, appsettings.json, you'll see this configuration, going back to configuration. What I can do is I can go over here and say, what do I call it? Logging. Save this. Look, program didn't reload. Everything's just logging now, right? Like, I can scope this down to a particular thing. So if I go to thing processor and man, debug isn't enough for me. I want verbose logs, right? Maybe I don't have verbose logs in there. Is that the one I had in? No, this is the other thing, thing doer. Nope, it's thing service. Well, I messed up my own demo, so. Let's see here, thing. Oh, I know. Yeah, so eventually you'd see, hey, there's a trace log in here somewhere, but anyhow.
So if you just put like logging debug and then logging.thingservice.verbose, it reads that just fine as well?
Mm-hmm. Yeah, you can add as many as you'd want, right? So, or you can go down to a specific namespace, right? So if like before I had logging, that's just the namespace and it gives every class in that thing. Here's where I ask you some hypothetical questions. Maybe ask real ones too, I don't know. Should you do any of these things? Like DI, well, are you using object-oriented programming? Some of you might be F# programmers. Some of you might not use any sort of object-oriented principle in your C# stuff at all. I don't know. Do you want to maintain low coupling between your dependencies? And do you want your project to be solid? That's probably reasons that you'd want to use DI. Configuration. Well, do you get your configuration from multiple sources? Do you need to change stuff at runtime? Do you want to change out what your configuration source is later, right? So this is more towards like, should I use app.config versus the iConfiguration stuff? These are questions that maybe you should ask yourself. And logging. Well, here's where I get on my pedestal. Yeah, you want to log stuff. I've seen too many programs where nothing is being logged. You have no idea what's going on. So you want to know what's going on with your program? I sure do. Do you want to dive down into a specific class's behavior? Well, this one will help you get there. Who wants a prize? This isn't a hypothetical question. Oop, I used the wrong command. So if you could, maybe on your phones, go to this URL. I'm going to change the thing out real quick. I'm going to take my program. Yeah, I can put it back up there in a second. Okay. Oh, that's an old game. Oh, that's the wrong one. Let's see here.
Jason, it says game over.
That's fine. The app domain didn't unload. I only spent so much time on this thing. All right, so basically, I already had a bunch of dependencies in here to run this distributed guessing game. And hopefully, it'll actually work. Nope. Let's look at our logs. Oh, there we go. I did bad things. Oh, I ran the wrong thing. I wasn't running the right thing. I ran the guessing game. All right. Does people see stuff?
Logs in your console.
Yeah. Look at that. People are joining the game. So I'm going to go ahead and get this game started by using this magical enter key. And so look at this thing. Man, I didn't test this at all. Oh, Bertrand. Who's Bertrand? Come up here, Bertrand. You have a prize. Come up here. Everybody, clap, please. No. You have a Nerd Rage bobblehead. All right.
Did you WebSocket this or Signal R?
Signal R. Yeah.
See, now I know you just want to be the most popular session here by giving things away.
I didn't telegraph that first, so you guys didn't know that before you came in. Anyway, here's some other stuff that I'm not going to go too deep on because I think we're running out of time, and I want you to have time for questions and stuff like that too. So I think John Galloway probably will be there tomorrow, right? And he'll probably talk about all this stuff a lot more in depth than I will, and he probably also understands it a lot better than I do. But there's a few things that came out recently that are really exciting for the .NET framework in total, and those things are spans, memory, and pipelines. So spans are basically a way to have a pointer to some piece of contiguous memory, like an array, a very large array, right? .NET is not necessarily the most efficient when it comes to copying a lot of stuff, and this allows you to have a kind of a stack allocated slice that allows you to look into a piece of contiguous memory, an array, a list, stuff like that, in a much more performant way. It uses this stack alloc keyword, which people may not have seen. This is to guarantee that the span is allocated on the stack, because it can only be allocated in the stack. It's one of the limitations of it. A memory is just a heap allocated way to produce more spans, essentially. And these, I don't have the benchmarks up here, but they have some pretty impressive benchmarks available on some of the Microsoft sites about what happens when you use these things. Same thing with pipelines. It's for high performance I/O, right? Also, it's a kind of a difference in how stuff gets done. So if anybody has ever used any sort of stream, like a TCP socket stream or stuff like that, right? You'll understand that you have to pull from the socket. You have to pull from that stream. And it's really hard to go back. It's really hard to peek at the data inside of there, right? The pipelines kind of overcome all of this. pipelines are a push model. Like I'm pushing stuff into the pipeline, and stuff on the other end is kind of observing it, and it can read it without consuming it. It's a lot more highly performant. I think it probably underneath it probably uses spans and memories probably. And it allows you to focus your consumption side less on the mechanical aspects. Like if you ever had to deal with a TCP socket, right, you have to set a buffer. And then the buffer, like the thing might not be done. You might not have the end of the file. You might not have the end of the stream. So you have to go continually build this thing. The memory footprint might grow if it's a long message or something like that. Pipelines help reduce a lot of that volatility, and it really hides the thing you're actually trying to do with that stream, which is probably something that's more valuable than handling some TCP socket. Some other things I think are important to mention. So caching is one of those. It's one of the two big problems in computer science, right? One is naming stuff. 2 is cache invalidation. 3 is off by 1 errors. So I just think it's important to note that Microsoft has made a distinction between caching mechanisms. It's an important distinction that you have a memory cache, and that stores live objects, versus something that might be distributed. Now they have an implementation, this might be a little confusing, called an I-distributed memory cache. But that's really just to treat it like as if you're developing on your local or something like that, and you want to act like you have a distributed cache, but have it be in memory, right? That's what that interface is for. But I think it's just important to note, like, hey, I'm making a deliberate choice to store this thing in memory and to keep it live versus I intend to cache this thing in some other thing like Redis or SQL or whatever, memcached. Other thing I think is really important, this changed, I mentioned earlier, HTTP context, right? So if you want your HTTP context, you need to use this, HTTP context accessor, right? It replaces the HTTP context.current, and it is async safe. I don't know if anybody's ever accessed HTTP context.current, tried to get something out of there, done a await on something, got it again, and then something blew up. Something wasn't there. So the old HTTP context was had thread local storage, and your tasks may come back on different threads, and thus they might not be there anymore. But this overcomes that. So it's a really nice feature. It's nice to use, help modernize your code bases. Some final thoughts. Do you have to use all this stuff? Should you use all this stuff? I mean, it's cool if you're making something new and stuff, but probably have programs you're already using. If you have an application that's working, and it's making you money, I don't know, maybe it should keep making you money. I think a lot of these things can be adopted piecemeal, right? You don't have to have dependency injection to do any of those other things. You can change your logging framework to be a better logging experience. You might gain a lot of benefit from that. You can have a better configurable program without having to implement dependency injection, right? Just weigh the things that you're doing, right, versus trying to just lump it all in, right? Understand why these things are being changed, not just the fact that they are changed and now I have to keep up, right? I think it's a lot of times we feel like overwhelmed by all the amount of change and stuff. If probably a lot of us have to deal not only with the changing dynamics of the back end, but I mean, there's the front end world too. That's chaotic. I mean, there's React and Vue and Redux and there's like all these other frameworks, like Knockout, what even happened to it? Who knows? And so it's easy to be overwhelmed, but it's also, you can run your own race. And that stuff is probably not going anywhere anytime soon, still supported by Microsoft. So when you get there, hopefully you'll have a better idea about what you're getting into. Thanks. Is there any questions? Cool.
I have a question about the logging.
Yeah.
We use Log4net, and so we
Yep.
build custom log headers and stuff. You didn't mention that, but I'm assuming that's supported in this too.
Yeah, they have an adapter to connect to the iLogging.
Okay.
Anybody else?
Making your code available.
Okay, so on this URL down here, right, should be links to all the GitHub stuff, all of the presentations, or you can go to demiz.io, and there'll be a link to that page from here. So links everywhere for everybody. Everybody gets a link. You get a link, you get a link, you get a link.